Today we're looking at intercepts and how to find them on a graph and in an equation. So if I look at this first problem, is the graph a function? So remember, we can use the vertical line test to see if a graph is a function. So we pass the vertical line test. There's only, at every x value, there's only one expected y value. Okay, so passes vertical line test. So it is, we start class in 10 minutes. Thank you, computer. Oh, I don't know how to get rid of that. Oh, that's my iPad. Okay, so it is a function. Okay. Function notation. Oh, I'm going to change this to a G. All right, so I should plug in a -6 for x, so I get 2/3, the x gets replaced with a -6 minus 1. I'm going to simplify by dividing out a 3 from the denominator, so then a 3 from the numerator. So 3 divided by 3 is 1, and -6 divided by 3 is -2. So I get g of -6 is equal to 2 times -2, which is -4 over 1 minus 1. So g of -6 is equal to -5. So when x is equal to -6, y is going to equal -5. Okay, so we're going to reverse this. This is the y this time. So I'm going to do 17/3 is equal to 2/3 times something minus 1. So I need to solve for x. I will add 1 to both sides. Another way to write 1 is 1/1. So to get a common denominator, I need to multiply the bottom by 3 and the top by 3. So I get 17/3 plus 3/3 is equal to 2/3 times x. All right, so I get, when I add fractions, I add the numerator. So 20/3 is equal to 2/3x. To get rid of the coefficient of 2/3, I'm going to multiply by the reciprocal of 3/2. The 3 divided by 3's cancel, and 20 divided by 2 is 10. So I get 10 is equal to 1x. So 10 is equal to x. So when x is equal to 10, I get 7. So when x is equal to 10, I get 17/3 as my y value. Okay, so intercepts. An intercept is when a point crosses the x-axis. So an x-intercept is when a point crosses the x-axis. Notice x-intercepts always have a 0 in the y. And then, so a y value is 0. And then when we have a y-intercept, the x value is 0. Notice the y-intercept here that crosses the y-axis is, the 0 is in the x, and then we get a value for y. Okay, so standard form of a linear equation is written like this. It's like ax plus by is equal to c. So it's like a number times x plus a number times b is equal to some other number. Okay, so a variable is a placeholder for a number, so something that can change. So x is a variable, y is a variable. Parameters are a, b, and c in this case because they're a number that we plug in. Like, different linear equations can have different a, b's, and c's, but they stay constant for that one equation. Okay. All right, so to find the x and the y-intercept on a graph, what we're going to do is just look at the graph, and I look for where the line crosses the x-axis. So crosses the x-axis. I see it crosses here at -2. So the x-intercept is going to be, remember the y is always 0 in an x-intercept. So the x-intercept would be -2, 0. The graph is counting by 2, so be careful there. Okay, the y-intercept, it looks like, is crossing at 4. So the y value gets the 4, and then we move 0 units away in the x direction. So I stay right on 0 and then just move up. Okay, so the x, oops, x and y. Okay, so you do this one and then you check. So the intersection of the x-axis and the y-axis. The x-axis has an intersection here at 1, 2, 3, 4, comma, 0. The y-intercept is 1, 2, 3. So it's 0, comma, 3. This is our x and our y value of the ordered pair. Okay? All right, so the next one, okay, x-intercepts, we'll start on the x-axis. There's 3. There's 1, 2, 3. So I'm going to list 3 of them. And the y is always 0 in an x-intercept because we're not moving any direction in the y direction. So my x-intercepts are at -1, 2, 3, 4. -4, comma, 0. And then the green one here is at -1, comma, 0. And then the blue one is at 2, comma, 0. All right, for the y-axis, looks like we have an intercept at -2. So the x is always the 0 because we're moving 0 units left and right. We're only counting up and down from the origin. So 0, comma, -2. If you are a function, you can only have one y-intercept. All right, last one. So x-intercept on the x-axis, it looks like we're counting by ones here. So this would be 1, 2. So -2. So the x-intercept would be at -2, comma, 0. And then it looks like there's another one here at 0, comma, 0. Okay. And then the y-intercept also at 0, comma, 0, because that's where the graph is crossing the y-axis at y is equal to 0. All right. In a table, it looks like it says we need to find the x and y intercepts, and then we need to write them as an ordered pair. Okay, so in a table, we're always looking for where the x is 0 and where the y is 0. So remember, does an x-intercept have an x of 0, or does a y-intercept have an x of 0? Okay, the y-intercept has an x of 0, so this would be the y-intercept is at 0, comma, -4. And the x-intercept has a y that is 0. So 0, comma, 2. Okay. If I were to graph these, 0, comma, -4 would be 0, comma, 1, 2, 3, 4, be like right here. And then 0, 2, comma, 0 would be on the x-axis. Okay. All right. Your turn, and then check your work. Okay, so I found my x-intercept where the y is 0, okay, is at -3. So I'm looking, is there anywhere else where the y is 0? No. Okay, so now I look, x is equal to 0. Ooh, right here. Last ordered pair. When x is equal to 0, y is equal to -3. So if I were to graph this, the x-intercept, we'll write it in green, is at -1, 2, 3, comma, 0. And then the y-intercept is also at -3, but on the y-axis, and I'll write it in purple. Okay? All right. Let's see if we can pause this. For these next problems, we need to identify the x and the y-intercepts from the equation. And then we're going to write them as an ordered pair. Okay? So I have my equation, 2x plus 3y, I'll change that. 2x plus 3y is equal to 12. And I want to find the x-intercept. So I need to plug in 0 for the y value. So I'm going to start with 2x plus 3y is equal to 12. And instead of y, I'm going to plug in a 0. So I get 2x plus 3 times 0 is equal to 12. 3 times 0 is 0. Okay, so I just bring everything else down. And then I get 2x is equal to 12. Divide by 2 on both sides to isolate x. So I get the x is equal to 6. So my x-intercept would be 6, 0. When I have an x value of 6, my y value is 0. Okay, next up, we find the y-intercept for the equation 2x plus 3y is equal to 12. But this time, instead of y being 0, we have to substitute in x for 0, because we know that on a y-intercept, the x is always 0. Okay, so I have 2 times 0 plus 3y is equal to 12. 2 times 0 is 0, plus 3y is equal to 12. So I get 3y is equal to 12. Then to isolate y, I divide by 3. So I get y is equal to 4. So when x is equal to 0, my y-intercept would be 4. Okay, your turn. Give it a try. Your turn, your try. And then you check the work with me. All right, here's what I did. I did negative 5x plus 4y is equal to 60. I know that I plug in 0 for y to find an x-intercept. So negative 5x plus 4 times 0 is equal to 60. So negative 5x is equal to 60 because 4 times 0 gives me 0. So divide by negative 5. I get x is equal to negative 12. So same thing for the y-intercept, except remember the x is your 0. So negative 5 times 0 is equal to plus 4y is equal to 60. So that goes to 0. So I get 4y is equal to 60. Then I divide by 4 on both sides to isolate. I get y is equal to 15. So my y-intercept is 0, 15. All right, next, let's try again. This time we're going to use function notation. Remember, f of x is just a fancy way to write y, okay? So to find the x-intercept, I plug in 0 for y. So instead of f of x, we're going to plug in y, or 0, sorry. So 0 is equal to negative 3x plus 4, okay? And then we're going to isolate x, so subtract 4 from both sides. I get negative 3x is equal to negative 4. Then divide by negative 3 to give me x is equal to a negative, divide by a negative is a positive. So x is equal to 4/3. So at 4, basically 1.3 bar, 0, we have an x-intercept. It's okay to have a decimal. Totally legal, okay? All right, so this time for the y-intercept, we plug in 0 for x. So f of 0 is equal to negative 3 times 0 plus 4. So f of 0 means the y at x equals 0 is equal to negative 3 times 0 is 0, so 4. So the y, basically this means y at x is equal to 0 is 4. All right. So your turn. Okay, this time we have our y is going to be 0 to find our x-intercept. Remember, y is just h of x. So I get 0 is equal to 1/2 x minus 9. So I add 9. So 9 is equal to 1/2 x. To isolate x, we need to get rid of the 1/2, so multiply by the reciprocal, so 2 over 1. So I get 1x is equal to 2 times 9 is 18, and then 1 times 1 is 1, so 18 over 1. So my x-intercept is 18, 0. All right, last one of this kind. I have x, y. To find the y-intercept, we plug in a 0 for x. So if h of x is equal to 1/2 x minus 9, I want to find h when the y value when x is equal to 0. So x is going to be replaced with 0. So I get 1/2 times 0 minus 9. 1/2 minus 0, or times 0 is 0. So I get 0 minus 9. So h of 0 is equal to -9. Again, this is y right here. This means y when x is equal to 0. So the y when x is equal to 0 is -9. All right, so how do we graph a function from standard form? Well, we have to use our x-intercepts, okay? So first, we're going to I'm just going to check something, make sure we're all good. Okay, we're going to stop there for right now. All right, we're going to graph the linear equation using our x and our y-intercepts. So really what we need to do to graph the equation of a line is we need to find 2 points on the line, and then we can connect those 2 points, okay? So I have the equation 2x minus 6y is equal to 18. So to find the x-intercepts, I would plug in 0 for y. So I do 2x minus 6 times 0 is equal to 18. 6 times 0 is 0, so I get 2x is equal to 18. Divide by 2, I get x is equal to 9. So I have an x-intercept at 9, 0. So I'm going to graph that. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 0. Okay. To find the y-intercept, you plug in 0 for x and then find the coordinating y value. So I get 2 times 0 minus 6y is equal to 18. So 2 times 0 is 0, so I get negative 6y is equal to 18. Then divide by negative 6, so we get y is equal to negative 3. So I have a y-intercept of 0, negative 3. So I'm going to count 0x in the x direction, and then 1, 2, 3 down. And then we go ahead and we connect these values. That's almost straight. It's a little funny. Okay. Like so. So find 2 points on your line. Because the graph is written, or because the equation is written in standard form, I like to find the x and the y-intercepts to graph, and then I can just connect the 2 points once I get those. Let's do one more of those. So you have 12x plus 10y is equal to 60. So we need to find our x and our y-intercepts. So for the x-intercepts, remember it's something, 0, and for the y, it's 0, something. So we're going to plug in 12x plus 10 times 0 is equal to 60. The 10 times 0 is 0. So I get 12x is equal to 60. Divide by 12. So x is equal to 5. So I have an x-intercept at 1, 2, 3, 4, 5, 0, and a y-intercept at 12 times 0 plus 10 times y is equal to 60. 12 times 0 is 0. So I get 10y is equal to 60. Divide by 10. Get y is equal to 6. So I have a y-intercept at 0, 6. So 1, 2, 3, 4, 5, 6. And once I have that, I can connect these. That was not super pretty, but ideally you'd have a ruler. I don't have a ruler with me right now on my iPad. Okay. And so that is that. We're going to skip this part for right now and do that on tomorrow's lesson. So I hope that you guys have a great day. Thank you for